Good afternoon, everybody. It's a great pleasure here to be with Ignacio to present what we've been doing to integrate ProActive, Parallel Suite, and OpenNebula. And we will attempt to also do a real live demonstration of this integration during the presentation, even though it's very short. So, Ignacio, do you want to say a few words to start?
So to show the complementarity of both technologies and to provide, a full stack, for cloud computing.
So let's get quickly to the matter. So we give a reminder about ProActive and OpenNebula, and then we show the integration and the demo. So one strong thing about what we are presenting to you today is the capacity to dynamically deploy workflows which come from ProActive capabilities to manage dynamic workflows that can execute on both physical and virtual machine. So with what you're going to see, you can actually achieve workflow treatment which can be executed on a physical machine or imply the dynamic deployment of virtual machine and the dynamic deprovisioning of those virtual machines. Okay, so originally ProActive was started within INRIA. We are located in Sophia Antipolis, so you can come visit us. And very early on, we had some industrial users we were requesting for support. Also, the software was open source. So we created ActiveEon companies 4 years ago, which I have the pleasure to head right now. And we have customers in various domains, which include IT, like Orange, for instance. We have customers in engineering, like IFP, in banking, like Dexia or GMO in Boston, in biotech, and also we now have a customer in China, in the IT and telco domain. So the software is used in a various kind of vertical direction, always for managing physical and virtual machine and to accelerate application. And the company is having a business open source model providing support and services. So basically in ProActive there are 3 layers. One which is integration of physical and management of virtual machine. So it's a cloud and grid IaaS, in the sense that in the same platform you can integrate the deployment and the management of physical and virtual machine. On top of that, we have orchestration and scheduling, which allows to have a multi-user, multi-applicative sharing of resource in order to have a single platform to orchestrate your application. And finally, on top of it, we have parallelization and workflows with ProActive Studio, which enables to dynamically edit, like we can see here on this picture, tasks and dependencies between the tasks, and to generate things that you will further execute on the orchestrator and use various kind of resources like we can see here dynamically. So I will hand on to Ignacio for the introduction to OpenNebula.
Yes, OpenNebula is a platform for building infrastructure as service clouds. It's an enabling technology to build clouds. So with OpenNebula, you can build your private cloud. You can optimize or simplify your existing resources in the data center or in your cluster. Okay, you can OpenNebula for this liberates existing hypervisors. We have support for Zen, KVM, VMware, and in the ecosystem we also have support for Hyper-V, for VirtualBox, or for OpenVC. With OpenNebula, you can also build your hybrid cloud. That means that you can access to remote cloud providers when you have a fluctuated demand. When you have a peak of demand, you can use resources from these remote cloud providers. This is for cloud bursting or hybrid, or for hybrid cloud computing. And OpenNebula also exposes cloud APIs. Okay, we have an implementation of the Amazon EC2 API, and we also have an implementation of OCCI, that is a standard developed by the OGF. We also have a web management tool to manage the infrastructure. OpenNebula is a fully open source technology. Now it's being distributed in Ubuntu, Debian, and OpenSUSE, and will be part of the next federal release. It's fully open source, which is, I think, very, very interesting. It's an adaptable technology. I mean, one of the main advantages of OpenNebula is that it provides very important integration capabilities. So it's not difficult to adapt OpenNebula to fit into any existing data center. This is very interesting if we consider that cloud is an evolution of data center. It's proven because we have many users that are using OpenNebula in production environment. Some of them are using OpenNebula to run tens of thousands of virtual machines. It's powerful. Why? Because we are concentrated on the management of the virtualized data center. So when we started the OpenNebula project, it was more than 5 years ago, our aim was not to provide an open source implementation of cloud APIs, was to provide a tool for the comprehensive, for the complete management of the virtualized data center. That's the reason we have the most powerful functionality for the internal management, for the backend of the cloud. No locking, of course, this is fully open source. We provide an open architecture with give information about all the internal interfaces. We also implement standards and try to leverage existing standards. It's interoperable due to this implementation of the APIs. And it's a technology that is being released under an Apache license. Well, to give you an idea of the timeline of OpenNebula, OpenNebula started a research project in 2005, okay? And we created the OpenNebula.org project site, the community site. It was 4 years ago. It was in November 2007. We did our first release of software in March 2008, okay? And since that time, we have evolved this project as an open source project. And our last release of software, the stable version, was 3.0 in October. Here you can see our main milestones. For example, here the distribution in Ubuntu, the testing by external user, by CERN, of OpenNebula using tens of thousands of virtual machines. And we also started a commercial company because some of our users requested us to provide commercial support for the technology. This is also part of our strategy for long-term sustainability. And OpenNebula is also now part of Debian or OpenSUSE. I think it's also very important to remark that OpenNebula is a technology, it's one of the main technology spin-offs of Reservoir. Reservoir was the flagship of European projects in cloud computing. It was a project that started in 2008, in January 2008, and ended in 2011. It was a very large project. It was an 18 million euro project. And OpenNebula is the main outcome of this project. And now OpenNebula is also being used by many projects and is being funded by many European projects. To give you an idea of our users, we have like 2 different types of users. We have users, organizations, using the technology to build clouds. You have here some examples. We have here samples from different industries. For example, OpenNebula is what they use in HPC. There are many supercomputing centers that are using OpenNebula to build their clouds. We also have many examples in hosting. There are many hosting providers, mainly in Canada, in Europe, and in Australia and in the States, that are now trying to offer cloud services using OpenNebula. We have here many research centers like ESA or CERN. And we also have many telcos. I mean, there are many telcos that are using OpenNebula, both for building cost-effective solutions and also to build their premium offerings. OpenNebula is not only this open source technology that allows you to build your cloud. OpenNebula is also being used by many projects as a platform for innovation. We think that open source is a powerful platform for innovation and also for interoperability. And there are many European projects that are now using this technology. And we are very happy to collaborate with these projects because they contribute to OpenNebula, and it's also a very good way to quickly incorporate innovation and also to bring that innovation to our users.